Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. The other day, Sci-Man Dan came up with a standardized test of general science for 11-year-olds and administered it to a few flat Earth believers. However, I've come to the conclusion that it would be best if I came up with my own test. Now, the purpose of this test is to look at people that have, shall we say, alternative views on the nature of the Earth. Many times these folks have said that they understand the globe Earth model very well, sometimes even better than we do, yet they feel that it's wrong. So I thought it would be good to go ahead and just test their general knowledge of the globe Earth model. So without further ado, let's get into the test. Okay, question number 1. Given a box of length, width, and height, can we describe every point in that box using X, Y, and Z coordinates? If we place an object in the box, can we describe every point on the surface of that object using those same X, Y, and Z coordinates?
I would say yes.
Yes to one or both?
100%. I would say yes. That's my answer.
To one or both?
I would say that it takes much more than just an X, Y, and Z coordinate to know what's actually in the center of it. If you're placing a rock in the center of that, then it's going to take more than the X, Y, and Z to know exactly how that rock is actually formed rather than just the X, Y, and Z.
Is the question related to how the rock is formed or the surface of the rock?
You're talking about what is inside of that. So
no,
if you're
I'm talking
asking
about
what is inside of that.
No, the question is, can you describe the surface of the rock with X, Y, and Z coordinates?
No.
Okay, so you say no.
The coordinates of no, because listen.
No, that's your answer.
No, can I clarify my answer, or are you just going to cut me off?
It's a yes or no question.
No, it's not a yes or no question, and that's where you're trying to trip us up. Because that rock is much smaller than what's happening on the barriers of what's outside of that. So the rock has a certain shape to it, and then the outside has a certain outside perimeter to that. So yes, you can explain what's happening to the perimeter with the X, Y, and Z, but what's happening on the interior and what that actually looks like, no, there's more details. But the perimeter, yes, X, Y, and Z would be fine.
What is the perimeter? What do you mean by perimeter?
The outside barriers.
What's the outside barriers?
Your box.
Okay, so the box. Is the question regarding anything outside of the box?
No.
I never said that it was.
With the right apparatus, yes, you can get it. So I would say yes, I stay with that answer.
All right. But you disagree?
Not me. No, I say yes.
What is longitude and latitude?
It's reverse
a Cartesian grid system.
And does longitude and latitude describe a single spot on the surface of the Earth?
With the coordinate system, yes.
Given the latitude and longitude of cities, can we calculate the distance between those cities? If so, how do you do it?
We'd have to first determine whether or not they are at those positions.
How would you do
Relative.
Direct measurement.
Yep.
How would you directly measure it?
Using some sort of instrument, tool.
An apparatus.
And what would you be measuring?
Distances in all directions.
What does distance have to do with a position?
The distance between 2 points, if it's on a grid system, would have to be verified.
Okay, the question was, given the longitude and latitude of two cities, how do you calculate, specifically calculate, the distance between those two cities?
With an angling measure device.
Oh my god.
How would you use an angling
very-
measurement device?
That's actually a very vague question. You
It's
can
so
open it. You
vague.
need to be more specific.
He's meaning his questions to be vague. Were you here from the very beginning? His questions are super vague. He wants a yes or no answer. Otherwise, we're dumb.
Hold on,
It's
you can
super
use a
ridiculous.
protractor and get angles, and if you assume the distances were measured right, you could use the angle and the headings and stuff like that.
Mhm.
I wouldn't
So
need
you
to
wanna
calculate
use a
anything. I could just get a
protractor?
measuring stick.
You could use a protractor.
Hold
Sure.
on. Yes, you can use a protractor if you're using it on a map.
On a map.
Hmm.
Yeah, like a 2-dimensional map.
Okay, but you can't give me a way to use a formula to calculate the distance?
Calculations aren't measurements.
Ding,
Okay.
ding, 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 ding. I'm glad somebody finally got it.
Welcome to Flat Earth, Bob.
Are rulers, protractors, and compasses natural objects?
That's the question. No, they're synthetic. They're man-made.
The material, the chemical substances of those objects are natural. But just like a recipe, they're constructed by men.
Yep.
Okay.
Which makes them synthetic.
And can we use them to measure things? Can we use them
Yeah.
to measure things?
Yes.
So
Not all three of them.
It doesn't have to be a natural object to measure things?
Well, if you want to make a convention, then you can use a man-made object.
All measuring devices and tools are man-made conventions, right?
From what I understand, yeah. Unless
Yeah.
you're
They're
using
not
like the
natural.
sun. That's a
Made from natural materials.
But those three items are not natural items? Or are they?
No, they're synthetics. They're
Okay.
man-made.
Can we physically measure the exact difference between 2 points?
Yes.
geometrically, yeah, on a piece of paper. Or with any direct measuring device.
So we can measure an exact distance
Yeah, with direct measuring devices.
with direct measuring devices. Okay. What is the difference between precision and error?
Use a protractor on the Earth or on a map.
That's not the question that we're addressing. We're addressing the question, what is the difference between precision and error?
Well, precision is precise. That is exact. Error leaves room for doubt.
Precision is a degree of accuracy.
Sure, but it's still more precise than we want error. Error is like
Error
okay.
would be outside of that precision.
Yeah. Yes.
It's,
Agree.
and it's acceptable, and that's determined by the person and the people using it. What acceptable error you're requiring in whatever measurement you're doing.
Can we use a protractor to measure the angle between two lines? Can we use a protractor to measure the angle between the arms of this compass?
Yes.
Absolutely.
Does the angle change if we move the compass? And does the angle change if we put an object next to the compass?
You
Does
say the
moving
angle doesn't
Does
change,
rotating
but
the compass
relative.
change the angle?
No.
Does putting an object next to the compass change the angle?
Of the compass? No. Well, I mean, I like to go back to the last one. It depends if you're trying to go based off coordinate system. Then yeah, it would change it relative to that. The questions seem a little vague. They're convoluted a little bit.
The question's very straightforward. There's an angle between the arms of the compass. We've agreed to
Sure.
that. If we
Sure.
rotate the compass or we put an object next to the compass, does that change the angle between the arms of the compass? Is it still X number of degrees?
Yeah, okay. Keep going.
Right.
I thought it was a trick question.
It's not a trick question. There are no trick questions here. Does measuring an angle between two lines require that the lines be connected into a triangle?
To get an accurate measurement.
How will connecting it to a triangle change the measurement of that angle?
Isn't that
You're only
plus b squared equals c squared?
That's not what we're looking for. We're not looking for the hypotenuse, but yes, you can.
Okay.
You don't need to. You don't need a lot. You don't need a triangle to measure just the angle
You
of
don't.
two lines. You do not need
You're
that.
right. You're right.
Does trigonometry require that we use a triangle? Do angles
Yes.
only?
Yes, trigonometry is triangulation. There's 5 type of triangles. I mean, like what? Yes.
So your answer is yes. In order to do trigonometry, you can only work with triangles.
Yes.
Everybody agree with that?
I agree with that.
Do angles only count if they are part of a triangle? Can we use trigonometry on a circle?
Yes.
Okay, so the last question, you said you had to have triangles for trigonometry, and now the answer is you can use trigonometry with circles?
On a circle. The question was on a circle.
Can you do trigonometry on a circle?
Yes, you can do a triangle within a circle. Yes, 100%. You can put yes.
On the
3
surface?
sides in the circle.
Okay, so
You said on a circle, right? You said
circle.
on.
So on the surface of a circle.
You can draw a triangle.
Okay.
A Euclidean circle.
Yeah.
Okay.
Not
Circles are 2D anyway.
Yeah, it's 2D anyways, right? You know.
Does the dip angle from the bridge of a ship at 10 meters height above the water change depending on what direction you're looking at the horizon? Did you hear the
I
question?
wouldn't think so. Well, if you're seeing the horizon from every point of the ship, all you see is horizon. It should all be the same, right?
The question is does the dip angle change based on the direction you're looking at the horizon from the ship?
I don't think so, but I don't know.
the direction.
Yeah. So if you're looking at the horizon to the north and you have a dip angle down to the horizon, and you turn around and you look at the horizon to the south, is the dip angle any different?
No.
It shouldn't, being that the ocean is level. It shouldn't in this demonstration.
Well, actually, let me jump in. Actually, it doesn't matter whether you're on a sphere or on a globe. If you're rising above surface or sphere, the angle to the horizon that you're looking at should be the same all the way around the ship.
Can we measure the apparent angular distance between the beak and the feet of that bird by looking at it?
No, you can calculate it. You won't get exact measurements.
So your answer is you cannot measure the angular distance between the beak and the feet of the bird.
You're going to get a calculation. You won't get a measurement. Those are two different things.
Well, actually, you can get the angular size of the bird with your instrument.
You can get that. What you can get a rough estimate of what you're seeing, yeah, but you're not going to get exacts. I know where this is going. This is going to be funny.
Is that your answer? That you
Yep.
cannot measure it?
Not physically, no.
Okay. Do you see the illustration?
Yeah, I see it. I'm looking at it.
That would only be measured in the degrees of the optic itself,
Right.
unless you had known distances.
Right.
Well, you notice
Agree with
that
that.
has gradations on it.
You know
And
what the
those
state of?
gradations are listed as 1 mil.
Oh, yeah, the stata. Lower, upper. Oh, yep. Okay.
All right, so
Sure.
I'm going to ask the question again. Can you measure the apparent angular distance between the beak and the feet of that bird by looking at it?
Angle. I'd say angle.
You're getting an
Distance, that would be
angle of what you're
questionable.
seeing. You're getting
So
an
you
angle
are
of what you're
getting-
seeing.
You can't measure
You-
anything by looking at it.
So
No.
Okay, so are you getting an angular distance between the beak and the feet or not? I just need an answer.
Okay, I will say yes, you are. I would say yes, you are, but you're not knowing the distance between you and the bird you're looking at.
Yeah, I
And
would
that's
not
why I
know
would say
there.
that you can never measure it because you don't know the actual size of that bird or the distance or any of those things. So it's not a yes or no answer.
I don't believe the
Well,
size
he-
or the distance was part of the question, was it?
The angular
Exactly,
distance
that's
based on
why
the
you keep trying
reticle.
to do this trickery where you want a yes or no answer, but it's more than a yes or no answer, but you skip to the next question each time because you're unwilling to hear all of the variables that actually matter. We
It's a
can't
simple
give you a
question.
yes or
Can
no
you
answer.
measure
It's
the
not
angular
simple.
size of that bird?
That's my
between the
issue is that
beak
you
and the
keep
feet?
asking. No, you cannot.
Okay, so
Because
yeah,
there's
you
not
can.
Science,
You
hang on
can,
a
you
second, let
can
me
use
jump
the
in.
reticle on the optic itself. It's got built in the measuring, so you can measure it.
I would say,
But that,
yeah, all
No.
measuring, wait a minute, all measuring devices, whether the one Bob is showing is a man-made convention, he can say, this is my measuring, and this is the units I'm using, and this is the angular distance or size of that thing. He can't do that, and that is allowed.
Yeah, but it's not true. So no,
Okay,
you
so-
can't.
Okay, so let me just
That's why I'm saying
jump
it's
in
more
real
than just
quick.
a yes or no.
So
Let me
Shine
just
says
jump in
no.
real quick.
Okay.
Let me
No, I say that it's more than just
So
a
let
yes
me-
or no. There's more to have a discussion
So let-
about. It's not so black and white.
It's not a
And
discussion.
you just
It's
no,
a
exactly.
the
You don't
question
want that.
says
That upsets you.
the question is can you measure the apparent angular distance between the beak and the feet of that bird by looking at it? And I'm giving you an example of what I'm referring to by looking at it here.
You give me the example of what you're looking at with that man-made thing. I would still say that there is still some muddy water there. Because
Okay.
what are we actually talking about? And what are you actually looking for? Because for me, especially, I know you and I know that there's something deeper that you're rooting for. And so all of these questions that you're asking them for a purpose and an end game. And so without that end game and knowledge, no, I can't answer whether it's a yes or no.
Okay, well, if you
That's-
don't want to take the
So-
test, that's
That's a
fine
valid
too.
answer.
Can you?
It's a valid
I say
answer.
yes, Bob.
Okay,
you
Bob,
so
I
your
say yes.
answer is yes. All right.
Can anybody
I'm
hear me?
recording the answer is yes.